This is a pyramid model PS-26KX regulated power supply. Voltmeter, amps. This is what it does when I turn it on. Protection. Refer to owner's manual when lit. So anyway, the owner's manual. Danger, high voltage. Refer to qualified technician for service. Well, yeah. Anyway, basically, it's just saying that overload protection is going to come on when there's too many amps or the voltage is too high. You know, there's nothing hooked to it, so obviously there's some other problem. So I've already got the top off of this thing. So I was just kind of looking over the circuit here, and I noticed, I don't know if you can see this, right in there. See, C9 is completely fried. That capacitor is completely fried, and then this transistor has been really hot. See that? See, it's kind of like charred there on the circuit board. I don't know if you can see that or not. And then also, right next to it, this capacitor, I don't know if that's glue or if that's something that's leaked out. See where it, like where it says X8, it's either glue or something has leaked out of the capacitor. So I think I'm gonna just try replacing those and see if that will fix it. On the schematic, this is the capacitor that's charred, and I think this is that transistor. It shows diode. It's SCR. I'm not really completely sure what that stands for. I'm gonna have to research that a little bit more. But I mean, it's obviously more than just a diode, because it's got another leg coming over here. Did I say C4 or C3? C9. Yeah, C9. Yeah, C9 is this right here. So it looks like it comes off of the power transistors through this VR1. VR1 is way up here. So I mean that wire goes over to the meter, which I think is this right. That's right there going. Okay, yeah. So see, here we go through the meter. That's the amp meter, and then basically through that, whatever that thing is. Also C9. And the big one with the leak is that right there, C7. Yeah, so C7 is that right there. So to me, it seems like something I wonder if that capacitor has gone bad, and that would go straight to ground. Maybe it's this diode. I should check that diode too. Anyway, something right here is amiss. So I'm going to replace this, and this, and check that diode, and then try it and see if that makes a difference. So anyway, SCR is silicone controlled rectifier. Silicone controlled rectifier, or semiconductor controlled rectifier, is a 4-layer solid state current controlled device. The name silicone controlled rectifier is and then thyristor is a solid state semiconductor device with 4 layers of alternating P and N type materials. It acts exclusively as a bistable switch, conducting when the gate receives a current trigger, and continuing to conduct when the voltage across the device is reversed, biased, or until the voltage is removed. And that's essentially what's on the schematic there, so I think that's it. So it's got cathode, anode, and a gate. And the middle, this wire, let's see, this red wire looks like it's going to the middle terminal, so that's anode, and that's coming straight from the output terminal, and then that goes right, basically straight over to the transistors, the power transistors. So I've been looking at this schematic a little bit closer. Power comes in here, goes to the transformer, goes through this rectifier, then the power comes over to the transistors. There's a voltage regulator here that controls the transistors. Then what comes off the transistors goes through here to this I think how this works is the power comes through here, and this SCR is like a switch. It's off, okay? And then there's a Zener diode over here for 16 volts. The max is supposed to be 15 volts output on this power supply. So I think what happens if this thing goes over 16 volts, it sends a voltage back and turns this silicone controlled rectifier on, and it would send the power to ground. I think that's how that works. I have never worked with one of these before, but I think that's what that does. So the power's coming off the transistors, hits this, and it goes to the output. You can't go any further than that because that's off. But if this goes higher than 16 volts right here, then it allows, on this Zener diode, it allows voltage to go back over here, turns that switch on, and sends the voltage to ground, I think. But I've got the parts. I had the capacitor in stock. It's a little bit higher voltage, so that should be fine. And here's the this is a capacitor that's going to be there for the C9. That's the one that's fried in the circuit. Had those in my stock, and then I've got these SCRs. They were pretty cheap. I think it was $9 for 5. The only problem, it says, caution, static sensitive devices not to be handled by unauthorized personnel. I'm not sure I'm authorized, Leroy. Yeah, I don't know if I can handle these. And then it's got a picture of, I'm not sure what that is coming off of that guy's hand. It looks like little chiggers or something. So I'm not sure I want to touch these. I'm not sure if I'm authorized. I've got this board loose, and look how fried that SCR is, and also that little capacitor. That thing is toast. Let's get that out of there. Okay, I've got this capacitor, which is C7 out, and you know, it's testing good. It's supposed to be 1,000 microfarad, and it is. I mean, it's right on, and it looks good to me. So that I might just leave that in there. And the stuff that, I think that was just glue. That's just glue, because it's not leaking out of the terminals or anything. It's not bulging. That was just glue. I think they glued those down to the board. So I'm going to put this back in. Okay, well, this is the little C9 resistor right there. Let's see how it tests. Well, I mean, it's not too far off there, a little high, but the ESR seems really high. So that's definitely bad. It's essentially a resistor now. There is the SCR. It has been fried. And let's see how it tests. It just thinks it's a resistor now. 0.17 ohms. And just for fun, we'll try to see how a new one of these tests. Tests just about the same. A resistor. That's weird. Is that how it's supposed to test? Well, I've got the SCR and the little capacitor replaced. That capacitor right there turned out to be okay, so I put that back in. So I'm going to go ahead and test it just to see if that is what it took to fix it. So here we go. It's plugged in. I've got it plugged into my current limiter. Turn that on. Let's put that on amps. See what we got here. Oh, at least we got the volt meter worked that time. That's weird, because it was almost all the way down. It was like at the max. So what? And it is putting out 15 volts, so that's interesting. This has no effect. The voltage adjustment has no effect. No amps, of course. And that's not getting hot or anything now, so interesting. Okay, so I think this is the voltage adjustment on the front panel. It's not really clear on the, it's blank where this hooks into the circuit board, and the circuit is a little bit different because it does definitely go into this R4, but this part right here is a little bit different. So I'm leaning toward thinking that it's something to do with this voltage regulator or this transistor right here. And the reason I'm thinking that is because it seems like it's outputting full blast. The transistors are outputting the full 15 volts. So I'm thinking it could be either this variable resistor, which should be pretty easy to check, this regulator, or this transistor that's in between the regulator and what turns on the transistors. The output transistors seem to be working because it's putting out the right voltage. So anyway, I'm going to give up for tonight, and then probably I'll start by testing this output control, and then maybe test some voltages on this regulator and also this transistor. Since the voltage adjustment doesn't appear to do anything, I'm going to check that. You know, it doesn't make any difference on the voltage coming out. I'm going to check that, and then I'm going to check actually where it's coming into the voltage regulator IC. And pin 4 is the input. And then it comes to this, looks like an op amp through a transistor. This is all in the IC. Output is 10. Right there, 10. Into this transistor, and then the output is what drives the power transistors. So I'm going to test this variable resistor just to make sure it's working. It's supposed to be 5K ohms. I'm going to test the voltage here on pin 4 while adjusting the voltage adjustment, and then I'm going to also test the voltage coming out of this IC at the output while I adjust the voltage here on the voltage adjustment, and then I'm going to check the voltage coming out of this transistor. Apparently this probably just like amplifies the signal that comes out of this IC before it goes into these transistors. I'm thinking that's what that does. So I'm going to try that next. It still doesn't explain why the buzzer is going off, but some of the outputs from this IC come down here and then come into this circuit that controls the buzzer and the LED on the front panel. So maybe it's something to do with this IC. IC 723. So let's check that out. I've got my meter hooked on this voltage adjustment pot, and when I turn it, yeah, it does seem to work, except it only goes up to just under 4,000 ohms. This says it's supposed to be 5,000. I mean, that should work. You'd think that would work. It might be a little flaky because it was, at first it was showing 5,000 ohms, and that's only showing 3,700 ohms. So I think that should work. It should adjust the voltage. It's not quite as much resistance as it's supposed to be, but it goes from basically nothing to 3,700 ohms. Now only 3,400. It's a little flaky. I've got the voltage adjustment all the way down, and I'm testing pin 4. The meter's hooked to the ground, the black lead hooked to the ground, and I'm testing pin 4 on the IC, and with the voltage adjustment all the way down, it's 9.8 volts, so basically 10 volts. And then with it all the way up, it's a little under 4 volts. And it's jumping around. It's 4 volts. Huh. Okay. And then on pin 10, 8, 9, 10, with it all the way down, it's almost 20 volts, 19.45. And turning it up, it's 19.16. So that seems like an issue right there. It's not doing much. It's not doing hardly anything. It's actually going down a little bit. You'd think it would go up. That's with the voltage adjustment all the way up on pin 10, which is the voltage out. And then on the emitter, with it all the way down, it's 24.8. And all the way up, it's 24.8. So it seems like this IC is not doing anything. So is it the IC, or is it something? Is it something around the IC? One of the other components. Let me think about that. I went ahead and replaced the IC since the voltages coming off of it didn't seem like they made any sense. I checked a few of the components around it. It didn't really seem like they were bad. They were in circuit, so it's kind of hard to tell, but I went ahead and just replaced the IC. I got 5 ICs on eBay with sockets. I installed a socket too, so I can pull that out of there if this fails again, assuming that's what is the problem. I got 5 sockets and 5 ICs for about $10, so it was a pretty reputable dealer too that had pretty good feedback in the past, so we'll see how this works. Anyway, I got it plugged in to my current limiter. Turn this on. I'm going to put that on watts, and then I got my meter hooked up to it. We'll see what we got here. Same. No difference. It's exactly the same. So anyway, well, guess that wasn't it. Got any ideas, Leroy?
No. Not yet.
Well, I've replaced both of the ICs and the SCR, and it's doing exactly the same thing. So I thought I'd pull out the power transistors and see if that could be the problem. So I should have probably done this a long time ago. Probably should have been one of the first things I checked, because that that SCR was completely fried. So anyway, these things are just testing as a resistor, so they're shot for sure. So I got some replacements. Not exactly the same number, but it seems like something that would work, so I will give that a shot. So just to test the new ones here, well, that looks right. So I'll stick these in and see what happens. Okay, so I got all the new transistors in there. It's kind of a little bit crappy how they just solder the... You think there'd be a socket or something, but I guess not. So there they are. Probably wipe some of the excess grease off of there. Alright, I got it all back together. I still have the guts. Got the guts hanging out here. Not touching anything here. Plugged into my current limiter. Let's turn that on. Put that on watts. I got my meter hooked up to the output. Let's turn it on. Volts all the way down. Putting out almost 6 volts. It's all the way down, so let's see if it'll so far so good. Let's see if it... I'm turning the volume, the volt adjustment knob. It's going up, and when I got to 10 volts, the fan kicked to a higher speed. 12 volts, and maximum is 15 volts. That's exactly what it's supposed to be. Hey, seems like it's working. I think it's fixed.
Cool.
Transistors are not even warm. I guess that's a good sign. There's no load on it though. Let's see what does the voltmeter, does it, yeah, see it's all the way down. That's saying 4 or 5.936 volts, and this is saying 6 volts. 6 volts there too, so that's good. How can I test the amps? Stand by. Alright, I just got this, it's an 8 ohm 100 watt resistor just across the leads there. That should give it some load. So let's see what happens now. That's not good. I'm not sure why I did that. Is it too much? I'm not sure why I did that. I'm not sure why. I'm not sure why it's doing that. The ohm, I mean the amps is coming up. It's like 1 amp right now. So I mean that. I guess the jury's still out whether or not that's working or not. I guess I could do the computation to see if that, if 8 ohms.
I smell something.
You do? Is 8 ohms? That's kind of warm. 8 ohms at 15 volts. Is that 1 amp? I guess I need to do the computation. All right. Well, at this point, it seems like it's working, but the jury's still out whether or not the amp meter is working. So, what do you think? Is it working, Leroy? What do you think?
I think it is.
You think it is?
Mm-hmm.
All right. Let's put it back together. All right. Well, it's been running for a while now, and there's no smoke coming from it, so I guess that's good. Everything seems to be working. And just to recap, first thing I did was replace this. The two obvious things, these things were fried. I mean, obviously they're cracked and burnt, and it's essentially it's this silicone controlled resistor and this capacitor, and that what that does, it just when it senses too high a voltage, is it voltage or current? One of the two. It opens up and sends all the voltage to ground. I think that's how that works. But anyway, those two items were the obvious things, and then it still didn't work after that, and I went ahead and replaced the voltage regulator, which is right here, and also the this whole section right here is just this one IC. It's a bunch of op amps. And I went ahead, since I'm going to use this thing on my workbench, I went ahead and put sockets. Before, they were just soldered right into the circuit board, so I went ahead and put sockets so in case they go out in the future, I can just pop those right back in, pop a replacement right back in there. So I think what really was wrong was these transistors, these power transistors, because they're all shorted. So anyway, I paid $20 at a thrift store for this thing, and I think these were about $8 total for the transistors, and you know these, I mean that's like a penny, and the silicone controlled resistor, I don't know, I think I got 5 of them for about, they were about $1 a piece, and then the same with these things were about $1 a piece. So for about, you know, $20 more max, I've got $40 in this thing, and I think they're about $150. So that's pretty good. I'm going to use this on my workbench. So anyway, that's it. Any more to say, Leroy?
No.
You don't have anything else to say?
Mm-mm.
All right. Thanks for watching.